Assalamualaikum warahmatullahi wabarakatuh. In this video, our group will demonstrate a smart lighting system using ESP32, blink, and walkway simulation. The components used in this project are ESP32, an LDR sensor, a PIR motion sensor, one LED, and one resistor. The LDR sensor is used to detect light intensity. The PIR sensor is used to detect motion, and the LED acts as the lamp output. In this circuit, the LDR sensor is connected to pin 34 of the ESP32 as an analog input. The PIR motion sensor is connected to pin 27 as a digital input, and the LED is connected to pin 26 as the output with a resistor to protect the LED from excessive current. And the sensor are powered using the 3.3 volt and ground pins from the ESP32.
In the program, ESP32 connects to Wi-Fi and Blink Cloud using the Blink authentication token. The LDR value is sent to virtual pin V0. The PIR status is sent to virtual pin V1 and the LED status is displayed on virtual pin V2. Virtual pin V3 is used as the control mode. The system has three modes: auto, manual on, and manual off. In auto mode, the LED will turn on only when the LDR value is above 2000 and the PIR sensor detects motion.
Okay, now we will run the simulation. So for step 1, we start the simulations before. We can start like this. Here we run the simulations. You can see that ESP32 LDR sensor and PIR sensor and LED are connected and it's ready to be simulated. And then you can see here uh, the control mode. We can switch it to off or on conditions. So when it's off, the strings value 2 will automatically tell us that the control mode or the switch mode is off, and if we switch it to on, and it will turn automatically to on. So the step 2 is the bright conditions where the LED is off. So we will observe the LDR sensor under a bright conditions. Because the LDR value, we make it to below 2000. It will remain that the LED will off. You can see the LDR here. And the system detects that the environment is still bright, so no lighting is needed. And then the step 3 is the dark condition without motions. LED will still off. Now we simulated the darker conditions where the LDR value reaches above 2000. However, since no motions is detected yet by the PIR sensor, the LED still does not turn on. So in the dark condition with motion detected, here are the dark conditions with the LED with the motions detected is on. So we trigger the peer sensor to simulate the motions because both conditions are now meet the environment is dark and motion is detected. The LED turns on automatically. So step 5 is motion stop or LED off. So after we turn on or we simulate the motion, it will turn off automatically. The LED will then showing that the system responds in the real time. For the last step or step 6, manual control via blink. Now we switch to manual mode through the blink applications. When we select manual on, the LED turns on regardless of the sensor. Like here, we switch it to off and the LED stop to light light up. So it's light off. If we switch it on and the LED will on automatically, like that. So in conclusion, this smart lighting system successfully controls a lamp automatically based on a light intensity and motion detections. It also allows remote monitoring and a manual control through the blink applications, making it both efficient and practical for a real use. Thank you.
So that's all of our explanation. And this is for our member. My name is Aleiandra Carissa Irawan with ID student is F1D02410034.
My name is Raissa Bunga Astrella with student ID F1D0 24 10087.
My name is Meisya Ananda Putri with uh, student ID number F1D01 2410072.
That's all from our group. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.
Atau